Hey everyone! So in this short lesson I'm going to talk about volcanoes and how they happen. You can use this lesson to complete the homework that I'll have set you. So we're going to find out what the causes of volcanoes are, we're going to find out how they happen, we're going to be able to describe the processes which cause a volcano to form and be able to do that for marks. Never forget that this topic also has links to loads of employability and loads of jobs out there, as you can see at the bottom of the screen. Okay, so let's get started with what is a volcano. Basically, a volcano occurs where magma forces its way through the crust of the Earth. And here you can see that happening. Where the magma forces its way through the crust of the Earth, it turns into lava. There are two types of volcano. The first type is called a shield volcano. And you can see in this image here how the tectonic plates of the crust are being pulled apart from each other. And that creates this kind of crack between the two tectonic plates. And you can see that the magma is almost leaking out of that crack that has been created. These volcanoes are not very explosive, not very violent, and you can see that the magma is flowing out quite gently. You wouldn't want to get too close, but they're quite calm and gentle. Here's an image of the kind of lava you would expect at a shield volcano. It's runny, it's quite slow moving, and it normally does not present too much danger to people. That said, it can be destructive, and anything that it hits, it will of course set fire to. The second type of volcano is called a composite volcano, and it's far more explosive and dangerous. A composite volcano forms at a destructive plate boundary. That means the tectonic plates are moving towards each other, not away from each other like before. And when they move towards each other, one of the plates is destroyed, pushed down into the mantle and destroyed. That creates a magma chamber that eventually forces its way to the surface to form a volcano. And when the pressure of the magma chamber under the Earth becomes too great, the volcano will explode. Volcanoes like this can lie dormant, that means sleeping, for thousands of years. And sometimes we don't even know that they're a volcano before they explode, which is quite scary. Volcanoes like this can create some really terrifying side effects, such as this pyroclastic flow. That is when rock and rubble is released at high speed down the mountainside, moving at hundreds of kilometers per hour, and moving huge amounts of ash, grit, rubble and lava bombs at superheated temperatures across the landscape. These features are called pyroclastic flows, and often they leave nothing behind. Even bacterial life is extinguished in their path. Here's more footage of a pyroclastic flow making its way across a landscape. It gives you an idea of scale, and it gives you an idea of speed. Really dangerous for things. So we need to get into plate tectonics. What are plate tectonics? Well, as you should know from class, the world is made up of layers: the inner core, the outer core, the mantle, and the crust. The crust is the bit that we're on, and it's divided up into different plates called tectonic plates. The mantle is made up of a solid liquid substance called magma, and it moves. It moves in something called a convection cell, where the hot magma rises, and as it rises it cools, so it sinks again. The friction between this flowing magma and the crust causes the crust to move. Sometimes the crust moves apart, creating a constructive boundary and a shield volcano. Sometimes the crust moves together, creating a destructive boundary and a composite volcano. These are the tectonic plates, and you can you see that they are all divided up. You can see that the continents that you're most familiar with from a regular map are merely the bits of rock that are sticking out of the ocean. Look at Africa. It's just the bit of the African plate that you can see above the ocean. In fact, Africa is attached to the far larger African tectonic plate. And that entire tectonic plate is in fact moving from west to east at around about a centimetre per year. The same can be said of Britain, which is on the Eurasian plate, which is a very large plate, and the entire rock mass of that tectonic plate is moving from west to east at again about a centimetre per year. Here between the North American plate and the European plate, you can see the country of Iceland that lies on the plate boundary. Because these two plates are moving apart from each other, it is a constructive plate boundary. And therefore, Iceland is in fact the product of millions of years of shield volcano eruptions that have built up so much solidified lava to create the island of Iceland. This graphic kind of demonstrates the convection cells you find inside the Earth's crust and how they pull the Earth's crust apart at some points and force it to be destroyed at others. Okay. This is a task we've completed in class. Use the keywords to complete the paragraph. Obviously, if you want to do it to gold standard, you should use your own words. But if you struggle, you can find me and get a help sheet. You should be able to also download a help sheet from the website, just next to this video. There are the answers when you're ready. Your task is to make an infographic poster that explains how destructive and constructive boundaries form composite and shield volcanoes. You should have a copy of these diagrams to assist you in that task. There are the broad instructions. You can collect a copy of the diagram and just stick it in and label it for bronze, but you can collect a copy of the diagram and label it using your notes for silver, and for gold you should add your own version of the diagram and label it using your full class notes, giving as much detail and information as you can. Okay, that's fantastic. Here are some final questions to think about. You should know at least 2 of the plate boundaries from this lesson, and from our previous learning of earthquakes, you should actually be able to name 3 types of plate boundary. Can you remember what the other one is that creates earthquakes? The mantle forces the plates to move. What's that process called? You could call it the process of plate tectonics, but can you use the term convection cell in an explanation of plate tectonics? And here's one to Google research for yourself. What is a subduction zone? Okay, I hope you found that helpful, guys, and I'll see you in class.